Okay, so let's get to work. Let's find out how we can find the antiderivative of this function. Okay? So we want to find the antiderivative of this function. And so what do we have here? We have a fractional expression, 3 over x minus 10, and let's say this is equal to f of x. And so we want to find the antiderivative. We want to find capital F of x. And so we're going to integrate that. Okay, so now here's the thing. It almost looks like it's in one of those forms. Okay? What form am I thinking of? 1 over x. If it's 1 over x, we know from the rule what the answer is going to be. But it's not quite there. So let's see if we can do a substitution of sorts to make it into the right form. So let's do that. So I'm going to make u equal to the bottom here because I want x, right? Or some variable up here. So let's make it u. So let u equal x minus 10, which means du will equal dx. So far, so good. So now let's substitute and let's pull the 3 out. And we got it. So guess what? Now we can just use the rule, and this is going to be equal to 3 times the natural log of the absolute value of u, don't forget the absolute values signs, plus c. And now all I have to do is put back in for x, which is x minus 10. So u equals x minus 10, so it's going to be 3 times the natural log of the absolute value of x minus 10 plus c. And we're done. That's it. So how about this one for you guys? Here's one for you. Let's go. Oh, hold on. Did I do? Oh, yeah. Hold on. So I'll have to write down the wrong one. Let's do, I don't want to give you that one. Let's see here. Oh, by the way, one last thing. Here, notice that, remember, this is where you have to remember the characteristics of a logarithmic function. Okay, logarithmic functions, okay, don't equal 0. You can't have 0 in there. Okay, because remember how logarithmic functions work. Okay, so this is a translation. So we know the natural log of x, right? How does the natural log of x look like? Or in other words, the absolute value of x. It looks like this. This way. Oh, ran it the wrong way. Oh, yes I am. Yes I am. I'm doing it right. It's going to be going back here. this function here, right? So we're trying to find the antiderivative of this function here. Notice in the domain here, we cannot have 10. 10 is restricted from the domain. So when we graph this function, it's 3 over x, right? That's what I meant to say. It's 3 over x, so it's a reciprocal function. And so a reciprocal function like this, 1 over x, looks like this. Like that. Okay, so in this case here, it can't cross 0, but in this case it's a translation, so it moves over to the right 10 units. Okay, so a little bit of, again, this is, I'm assuming you guys know how to do this from previous classes, but it bears repeating. So, with that in mind, we can't forget restricted values. So in this case here, we would say that x is not equal to 10. Okay. Not because we can't stick 10 in here. I was mistaken by that. Because 0, you can take the natural log of 0. Or no, you can't. Yeah, actually you can't. You can't take the natural log of 0. That's impossible. Okay, so also for the same thing here. But if it goes back to looking at the function, right? Okay, good. If you have any questions about that, ask me, reach out to me. I'd be more than happy to help you understand that. But this is the function we're talking about. So if you understand what this function looks like, and again, if you don't understand what it looks like, use your calculator and graph it. It's okay to use your calculator, by the way, when you're doing the homework to check your work or you want to improve your understanding. It's helpful to look at the graph, okay, if you don't remember the behavior and stuff. But again, on an exam, you're not going to have the calculator, so again, just be careful. Okay, that's it. Oh, I forgot to give you one. Here, you guys try this one. Find the antiderivative of this function. Okay, this is the one I want you guys to use. Use this one. We'll call it g of x. Okay, find the antiderivative of g of x. Have a great day.